Welcome to Imperial CAD system. In this video, I will show you this part pulley with arms in Catia V5 software. See here we have a pulley and 4 arms, and you can see its arms width is 20 mm, and when you see its section view here, these arms are tapered with like a 12 mm above and 18 mm below. So how to create this in Catia V5? For this we need to use shaft option. To create this, first I start from creating arms. After that, I create a pulley using shaft. First, if you see in the front view, you can see the width of the arm is 20 mm, and this is a section view x dash x. You can see section view and all the dimension is shown over here. So first what I do is I select YZ plane, I go to sketch, just I create only a rectangle of 20 mm width, 10, 20, and this arm height here it is shown. See here 276. So from the middle I give 276 by 2. by 2. On this one, something, this may be anything, because I use Boolean operation so that the bottom feature will be trimmed. And pad some mirror I give, both sides are 20 mm, let it be 20 mm, 40 mm total, and this is the front view of the arm. Then by seeing in the drawing front view, here the arms are straight, both sides straight, but when you view it's a side view. See from the side it is tapered, bottom 18 and above 12. Then in that case I go to get side taper, and also it should be circular. So it should be circular above and below. In that case I go to insert body, and this is a front view of the arms, so I take a side view reference, ZX, ZX position sketch, swap, yes. Here I take taper. This sketch is separately I am creating using body 2. Above I enter 12 mm, bottom 18. I make symmetric by giving half dimension, 9 bottom, 6 above. From the axis to above it is, see 12 mm distance. If you zoom that, here these 2 points, the distance is 12 mm, the dimension is shown downside, not somewhere here, it is at this points. So in that case 276 distance, from the middle 276 by 2. Okay, and from the center to this start, it is shown here 80 mm, 18 mm, 80 mm. So from the center it is 40, so that we are taking these arms exactly here. So here I give 40. Now we should not pad this. Here we should not pad. We need to use shaft option. Body to sketch, go for shaft. Select that profile. Axis, x-axis, not 360 degrees, I just give 45 degrees. On the other side also, minus 45. Directly I give 45. No need to give minus. In SolidWorks Creo we need to give negative values, but Catia directly positive values both ends. Now go to Boolean operation, intersect option. So intersect, select this body to the part body. See, then we get like this. The arms, it is like this. From the side it is tapered, and from the front view it is a 20 mm width. Then circular pattern, reference axis this one, 4, total 4 arms we need, 90 degrees. Now arms we get, and we create wheel now. 65 rounded above. Here in the section view you can see hatching portion. Just directly generate that hatching portion and go for the shaft. See, for that insert body, ZX plane. In this view, sketch, swap, that's it. Then I take an arc, (65) coincide the center, then height is given. To this point it is 290, so from the center it is 290 by 2. On this side also 45, same 145. That's it. Then go to profile, take profile like this, arc, take an arc like this. Just I'm taking random arc and connect. How much is this? Dimension is given 276 by 2. Create horizontal, make this horizontal so that it will be constrained. Sorry, not horizontal, vertical, should be vertical. I go back. Okay, it is vertical, then still why it is not constrained? Yeah, it is not coincided. This point and this point, right click, coincidence. Then this point, as we gave dimension this one 12 mm, same thing we need to maintain 12 mm as per the drawing. Say 12 mm should be here, from this point to this point distance 12 mm, maintain the same thing, 12. Six, I go back. So this we need to set keep the center coinciding with the vertical axis. Then towel. Yes. Then what else? So this is moving. We just coincide to this edge. Coincide center to that edge. Then that is fixed. Then downside also we need to make a same type of a drawing. 80 mm from the center is 40 mm, and the shaft hole die is not shown. We take 30 mm or 25 mm. 30 mm we take. So downside same 65. First I give width of 65. 65 by 2. Shaft hole, as it is not given, we consider 30 mm. So here I give 15 mm. Then coincide this to vertical axis, center to vertical axis. 18 mm this one. 18. Still it is under constraint. And finally from the center to this 40 mm, as that is 80 mm as per the drawing. 80 mm. That's it. Now simply go for shaft. Exit shaft axis. First select the profile and select axis. Total round we need for pulley. Same. Now we got like this. Then body, I add a color. We got a wheel pulley with arms. Then if you want to increase this shaft hole, say I want to increase this to 40 mm, then double click on the sketch. Instead of this 15 mm, do apply 20 mm. Then we get a shaft hole of 40 mm. Yeah, this looks good exactly as it is. Then you can see a keyhole. Here keyhole, length and width is not given. So I select this surface, I go to sketch. Take a rectangle of 10 mm or 15 mm. I enter 10. And this is 5 mm. 10 by 5. I make symmetric by giving 5 mm. Some value. Exit. Pocket. Up to last. Like this. Like this. We need to create a pulley with the arms. Thank you for watching this video. For more videos, share and subscribe Imperial CAD system.